All right. Today, everybody, we're going to look at solving quadratic equations by completing the square. So these are all quadratics, and they're in standard form. If you recall, standard form, just equations that have ax squared plus bx plus c. Now, this is just the left-hand side of the equations, but what I wanted to point out is on Friday, one of the jobs we had was to factor these. And these all factored as perfect squares. This was x minus 4 squared. And I showed this all on the video from Monday. I solved them all for you so you could see and tell if you were doing them correctly. But there's how they all factor. So these are all what we call perfect square trinomials because they all factor as these perfect squares, things we can square root. Now the pattern I want you to see here, that's important, involves the b term. Okay, so there's b, it's bx, so there's negative 8, and the b would be negative 10, negative 18, and positive 8 right there. And I want you to see this pattern. If I take this 8, divide it by 2 and square it, it gives me 4 squared, which is 16. If I take the 10 and I divide it by 2 and I square it, it's 5 squared, which is 25. If I take the 18 and divide it by 2, I get 9, and 9 squared is 81. And this 8, if I divide it by 2, that's 4 squared, which gives me a 16. So if that b term is divided by 2 and squared, it gives you the c value. The b term, I should say the b coefficient, divided by 2, square it, I get the c term. The b divided by 2, I square it, I get the c term. The b term divided by 2, I get the c term. And this pattern we're going to actually use and exploit to solve quadratics by the method called completing the square. It's called the completing this last term, like 16 is the middle term, the b divided by 2 squared. 10 divided by 2 squared tells you that c term. Or problem or method, because let's say I have a nice little equation like x squared plus 8x minus 5 equals 0. Now, this one does not follow the pattern. If I take 8 and divide it by 2, that's 4, and 4 squared should be 16 right there. It's not that. But we can rig this problem to make this left-hand side a perfect square and then solve the quadratic equation. So let's take a look at how we do that. And I'm going to try and write these down as steps so you can follow along. But step 1, take c, to the right side. Now in this case, our c value is the negative 5. Remember again, this is this ax squared plus bx plus c. So we're going to move this 5 to the other side in step 1. We'll just add 5. And that will yield x squared plus 8x equals 5. Now on the left-hand side, this is actually where we do the completing the square part. One caveat, and we won't have to deal with this today, so you got to make sure the coefficient in front of x squared is just a 1. If it was not a 1, for example, if it was 2, you just divide everybody by 2, and that would make this a 1 at that point. But we're going to write that down to step 2, divide by a, the a value. So again, in this case, we'd just be dividing by 1, so it makes no difference to us. 8 divided by 1 is still 8, 5 divided by 1 is still 5, so we don't have to do any will work if that a value is already equal to 1. Step 3. Remember now, we just talked about how so we set the problem up to do that. What we do is a little calculation, and we just go b divided by 2, and we square it. And that's going to give us what I've called in other math classes I've taught, the quote-unquote magic number, and you'll see why it's magic here in just a second. So let's take a look at the b value in this problem. So b is equal to 8, right next to the 8, or right next to the x, rather. Okay, so let's calculate b over 2. So 8 divided by 2, and we square it, which is 4, squared, which is 16. Okay, and all you have to do is add this to both sides of the equation. Let's put that in as part of our step. Now to make this a little clean, what I'm going to do, hopefully it's not going to let me move just a part of it. I'm going to do that calculation again off to the right here so we can see it, but it's 8 to b divided by 2 squared, which is 4 squared, which is 16, and that's what I'm going to add to both sides of the equation. So I've got my x squared, my 8x, and I'm going to add 16. But if I add it to the left-hand side, I have to add it to the right-hand side. That keeps it nice and balanced. Now, this is what we have just done. We have made the left-hand side a perfect square trinomial, and this is one of the things we practiced on Friday. This will now always, as long as you followed those steps, be factorable as a perfect square. On the right-hand side, you get whatever you get. In this case, we get a 21. But now we can use the square root method, and the problem becomes real simple to solve. We square root the left, square root the right. X plus 4 equals plus or minus root 21. Subtract 4, and we're done. And that's it. The method of completing the square. So let's write down a final step here. Factor the left side. To a perfect square. And then you can call it step 5 if you want to, but then solve with the square root method. And the square root method, again, just square root both sides. So let's take a look at another problem here. Okay, I'm not going to write down all the steps again. I'll just kind of walk you through them. Let's say we had x squared plus 10x minus 7 equals 0. So I got this quadratic equation. I want to solve it. Well, we could try to factor this thing. We could can't use the square root method on it. We could graph it. Graphing it would work pretty awesome, but remember, graphing only gives us approximations sometimes. So if we want to get perfect answers, we're going to have to use this new method of completing the square. So again, step 1, just add 7 to both sides. Get that c value over to the right. X squared plus 10x equals 7. Second step, make sure the a value is 1. It is, and your problems today are set up so it will be. Step 2, and this is where you have to do a little side math. You take the b divided by 2 and square it. So for us, the b value is 10, right next to the x divided by 2. We square it. That's 5 squared, 10 divided by 2, 25. And just add that 25 to both sides. So I've added 25 right there, and I've added 25 to the right, so I stay balanced. As soon as you've done that, this left-hand side is very factorable. X times X. To get the 25, they have to be the same number, so it will be a 5 and a 5. Both positive. This perfect square is what we have just made. Again, the right-hand side becomes whatever it becomes. In this case, a 32. And now we square root both sides and solve it. And we're done. Boom. X plus 5 equals plus or minus root 32. I'm going to factor this so I can break it down a little bit. 32 is 16 times 2. That means I can square root the 16. And now I can take the 5 to the other side. Negative 5 plus or minus 4 root 2. Yes, it seems like quite a bit of work. That's because I'm explaining everything. I'll try and show you one here without as much conversation, so you can see in practice how generally it looks. I subtracted 5 from both sides. I check my a value is 1. I take b divided by 2 and I square it. I add that 36 to both sides. The left-hand side is now a perfect square, and I've built it to be an x plus 6 squared. Square root of 36 is just 6, so I knew exactly what it was. The right-hand side I add, I get a 31, negative 5 plus 36. Square root. 31 is a prime number, so it will not factor. I subtract my 6. And I am done. I've got my 2 answers for this quadratic. And had I done this with the graphing calculator and graphed the darn thing with Desmos, they would give me decimal approximations for these 2 answers, but I could not be exact like I am now.